So what exactly is a lens? A lens is a specially shaped piece of glass or plastic that refracts light, and it does it for the purpose of creating images. Here we see something known as a converging lens, and you can see that all this light is coming in parallel. At the various surfaces, it's refracted, and it all passes through a single point called the focal point. Okay, and that's why we call it converging lens, because all the light converges on the other side. And I want you to notice that there is no refraction for the center beam. It's hitting the surface perpendicular, and of course that would create no refraction whatsoever. Here we have a diverging lens, and we've got parallel light coming in, and you can see the shape's different than the converging lens. This actually refracts the light away from a focal point that's on the same side as the parallel light. The light beam comes in parallel, and then the individual rays diverge, and hence the name diverging lens. Converging lenses and diverging lenses can also go by another name. Converging lenses are sometimes called convex lenses, and diverging lenses are sometimes called concave lenses. Let's look at some important features of lenses. The first thing we want to look at is this thing called the principal axis. If you draw a line that goes right down the middle here through the lens, that's called the principal axis. And probably the most important feature of a lens is its focal point, and that's the place where these, in the case of this lens, the converging lens, the parallel lights converge. There's also this notion of a thing called a focal plane. So if I were to draw a line perpendicular to the axis here and imagine that it's a plane, that's called the focal plane. The significance of the focal plane is that any rays that come in parallel and pass through the lens will focus onto the focal plane. Now these ones are special because they're coming in parallel to the principal axis, so they'll focus at the focal point. But you can have rays that come in parallel to each other but not parallel to that principal axis. They will focus on the focal plane. One last feature of a lens is a thing called the focal length. The focal length is literally the distance from the center of the lens to the focal point, and it's kind of important when we do some of the math of lenses. The way our vision works is that things that are far away are seen through a relatively small angle of view, and when they get up closer you have a larger angle of view. So when a lens magnifies an image, it just increases the angle of view that we see it through. We're going to take a look at this converging lens and see how it makes images. The object I'm going to look at is a picture of an arrow, and I'm going to focus on rays that emerge from only one part of the picture, the tip of the arrow. And if you see, there's some rays drawn out from here, and they pass through the lens and onto the other side. The way my brain and I operate is my eye, which is on the right-hand side of the lens, will see an image where these three rays converge. Okay, now of course there's many more rays. We're just focusing on a couple to make it a little more clear. Now, I don't see these things converging anywhere over here, but if I allow them to trace back to the other side, you can see all three rays converge back to this spot. This is the image I would see. Now this image has three characteristics. First of all, it's upright, which means it's the same orientation as the object, or you could just say it's right side up. It's also enlarged. It's bigger than the object. Now the third one's not so obvious, but the image is on the same side of the lens as the object itself. We call this a virtual image. Now, what I'd like to do is take this object and move it around, and you can see that we can change how much magnification we're getting. The closer we get to the focal point with the object, the bigger magnification we get. Now, that's one type of image we can make with a converging lens. We can actually make other types as well. If I take this object and move it out past the focal length, let's see what happens. All right, now what you're seeing here is this object is on this side. Rays are leaving the object, passing through the lens, but this time they're converging on the other side of the lens. And the result of that is that the image that I'm seeing is no longer upright. It's what we call inverted. It's still enlarged, but it's on the other side of the lens, which we call the real side of the lens. So this is a inverted, enlarged, real image. I'm going to move it a little further on so you can see something here, but these are the outgoing rays. These are outgoing rays too, but the convergence point is here. My eye is going to be over here, and I'm going to see this image back along these lines where they converge. Now, real images are kind of special. Real images, because they exist in a place where light actually crosses, can be projected on a screen. So if I were to take a screen and put it up here, right now, I'd have to back it up a little bit, but if I focused it right on that screen, now we don't have an image anymore, but we would actually be able to see an image of the arrow projected on the screen. Let's get back to our arrow. Okay, so right now, if I had a screen in this position, you would see that image on the screen. This is how projectors work. Now, if I take this object of mine and move it around, right here we said we had an inverted, enlarged, real image. If I keep moving it further out, say out to here, what you can see is that it's still inverted, it's still real, but now it's a reduced image. This is a smaller than the object image, and we call that reduced. Let's just kind of recap this. There's three types of images we can create. We can create the upright, enlarged, and virtual image. We can create the inverted, enlarged, and real image. And then if we go out far enough, we can create the inverted, reduced, and real image. Now we'll take a look at the image characteristics of a diverging lens. This is the object right here, the big tall one, and rays that are emerging from its tip converge back to a point which is the tip of the image right here. You notice this doesn't show the focal point. It turns out it is important, but it's not as important for a diverging lens. And the reason is because if I move this object around, it really doesn't change the image that much. Out here, you can see we have an upright, reduced, virtual image. If I move it in closer, it's upright, reduced, and virtual. It has not changed image characteristics. It got a little bigger, but it's not significantly different. And that is the only kind of image you can create with a diverging lens, is an upright, reduced, virtual image. All right, let's see if we can't recap this. For a converging lens, if the object's inside the focal length, the image will be upright, enlarged, and virtual. If the object's past the focal length, the image will be inverted, real, and either enlarged or reduced. For a diverging lens, if the object is anywhere, the image will be upright, reduced, and virtual. Thanks for joining me.